again. Right. Okay, let's do that again. Let's do it properly. So, as you probably saw in the fast forward, I was testing this. This is our little spaceship, as represented by a cube, flying along Bezier curves. And this, at the moment, every time it finishes a curve, it then re-rolls, gets another random location inside a unit sphere, and then goes to that. As you can see, the green line is showing the path that it will follow. The little red bits on that is the current facing vector along that. I'll probably turn that off. That's just for debugging. The white line is the direct path between the start and the end, and the grey line is the control points. Now, the way this is working is the first control point is out the front of the current velocity the current rotation, so it always starts moving forward. And then the other control point, which is hidden, is backwards from the goal. So what will happen is it will start moving in the direction that it's already facing, turn around, and then turn into arrive at the goal at the right orientation. Yeah, so this will go around. It's there's still a few little problems with it. The rotation of the ship is a little bit weird. Sometimes that flips around suddenly. I think that's just to do with the way I'm using look rotation. But other than that, it seems fairly smooth. Right now, this is just moving 1% per frame along the curve. It's not doing any velocity or acceleration, which I'll implement at a later date. But right now, I just wanted to get it to follow the curves. So if I stop this and switch over to the code, right, we've got quite a lot of code here. I've got the Bezier curves thing, which I'll probably do a thing later on. That's just reading off of a tutorial which was on cat-like coding. So this is the URL. I'll stick that in the description. But this is cat-like coding. They've got a very thorough tutorial on curves and splines inside Unity, and creating editors to edit them. I've only implemented a small part of this. Basically, I've only implemented what I needed. But there's loads of extra stuff in there. So, right. So what we got is that's the Bezier code, the Bezier spline stuff, which to be honest, it's exactly the same as the tutorial. What we've got is we've got a list of curves. These are our navigation paths, or kind of like our paths between waypoints. We've got a Bezier curve, which is our current path. And then we've got the current progress along that path, which is a number between 0 and 1. We then got float velocity, float max velocity, and float acceleration. These currently don't do anything. Eventually these are going to get linked in with kind of like the fakey physics of the acceleration will be based on the mass of the spacecraft, the amount of thrust it has, that sort of thing. Max velocity obviously doesn't make any sense in a space game, but it's there just to kind of constrain the gameplay a little bit. So that's a kind of concession that that I think we're going to have to make for gameplay, is that yes, you could accelerate at 1g for half an hour and reach the speed of light or whatever. But is that going to be any use for gameplay? Probably not. So the max velocity is there just to kind of, I think pretty much every space game I've ever played, except maybe Kerbal Space Program, which actually does have a max velocity, but it's really high, has that. But anyway, that's gameplay. We're not going to do that now. So we've basically got our waypoints and a way of working out whereabouts we are inside this list of waypoints. We then got some public nav methods. These are in this region here. So these are the things that AI scripts and other things use to tell the navigator to go to places. And at the moment we've only implemented this navigate to location vector 3 goal. And that is basically really the most basic type of navigation that I wanted to implement, which is why I've started with it. And what that's doing is it's switching the state machine into go to when passing in the goal value. So just close up that. Oh, hang on. As you can see, there's also things here that do loads of things. There's navigate to dock, navigate to orbit, which will travel around. It will go to an object and orbit around it. Navigate to follow will follow a target, a game object target at a range, and it will continually update its navigation points. Navigate to come alongside is the same as navigate to follow, but it has an offset, so you could follow sideways or follow in front or follow behind an object. Add waypoint just adds a waypoint, so right now we've only got that, but the next thing to implement is basically adding in multiple waypoints, because these will all use that. There's also add a waypoint with an orientation, which will be used in things like the navigate to orbit function. And then we've got the navigate to transfer, which is a kind of a special case one. So the world map's split up into grid cells, which are 1,000 kilometers across. There's going to be a fast travel mode where the player can travel to another grid cell far away really quickly, in kind of like a warp drive type thing, and that's basically going to do that. But right now that's there, and it should be implemented in the first alpha. Everything here I want to get implemented in the first alpha. So let me close that region up. So then we've got a state machine, which is fairly basic. We've got an enumerator for the states. We've got a current state. We've got a delay, which is just the time between the state machine running through and re-evaluating things. And then we've got this enumerator state machine, run state machine function. This is basically a coroutine that's constantly running in the background of the navigator, updating the state machine. And currently we've got two states that are actually implemented. We've got state none, which at the moment what it's supposed to do is do nothing. What it's actually doing for testing is it's switching the state to go to another random position. So every time the state machine switches back to none state, it will then switch back to go to state and give it a new random destination, which is how it was cycling around different places. The second state we've got implemented is the go to state, and this basically all that does is sits there waiting for all of the execution to be finished. In the go to mode, it will basically go down the list of it'll execute the list of nav paths one by one until the list is empty, and then when the list is empty it will switch back to state none. And then we've got these empty states which don't do anything. I guess these probably should switch to state none, but because I'm not calling any function to do those, I'm not going to bother. And then finally we've got a yield return new wait 4 seconds update delay, so it makes sure that this switch statement evaluates every half second. That might be a bit slow, it might be a bit fast, I'm not sure. If we've got thousands of things all doing this, I don't want to kind of bottle it up all the time, to, like, you know, basically just plug it. Yeah, just fill up all of the execution time with re-evaluating the state machine, because it doesn't really do a lot other than switching states. So then we've got these states, which, to be honest, state goto doesn't do anything, but that here should be in there. Let me change that now. There you go. Let's try to get this so that it makes sense, yeah. Okay, so the state go to basically just waits until there's nothing left and then switches back into none. We've just discussed that. We've got state follow, which doesn't do anything, state orbit, which doesn't do anything, state dock, which doesn't do anything, and state docked, which doesn't do anything. Basically what these are going to do are, the follow one is going to continually every half second update its goal position to the position offset behind the enemy or the target. State orbit is going to loop adding in waypoints so that it will go in a circular path around an object. State dock is going to process through a number of different waypoints, and then it's going to switch into state docked. And state docked is going to be there until you tell it to undock. So that's kind of just like a holding there, not doing anything. But what it will do is it will lock its transform onto the transform of the thing it's docked onto. So if it's a drone docked onto another ship, in state docked, it will just move around with the ship, whereas the other ones, otherwise it's like a free entity and it will move around on its own. So then we've got the switch so these are like the state execution functions, and these are state switching functions. So switch state none means change to state none, so it clears the nav paths and it sets that to state machine none. Pretty simple. And then the next time the state machine evaluates, it will then do that, and it will then evaluate in state machine none. Switch state go to switches the state machine into the state go to, and you pass in and goal position. There's a number of overrides for this for various different things. So if we go down in order of complexity, switch state go to goal position basically just works out a vector to the goal position. It then switches state. It calls this other more complex override with more information. The switch state go to goal position and goal rotation is implemented, but it just does the same thing as the one above. And then we've got this switch state go to goal position, goal rotation, goal approach, and this is the thing that makes everything happen. So what this takes in is a position where it wants to go to, like a rotation that it wants to be in when it gets to that goal, and a approach vector that it wants to approach the goal at. Now the reason I've got this is because in docking you want to it wants to approach approach the docking port in a go down into the docking port. So this goal approach is basically what's giving us our direction to go in. So I think I've explained that right. If I've not, asked me on the Facebook group and I'll explain it. I'll probably put a diagram up or something as well. So basically a bit of log output so I know what's going on, just to say that the navigator switched into state go to. We're clearing the waypoints, or the nav path list. We're then getting the vector to between the current position and the goal position. We're working out the distance, and then we're working out the control point radius. The control point radius is basically 50% of the distance. I'll probably tweak this. This is basically the kind of the curviness of the path as it goes to get to its destination. I originally started that as 20%, and that was a little bit sharp. It was immediately like kind of flipping around and going to it. So it would like kind of go whoop straight in. Whereas this kind of, if it's facing the opposite direction, it will kind of smoothly go round towards the goal. So that's our control point radius, and actually in this mode, this is, we have a look, this is what gives us the lengths of these grey lines here. And as you can see, the length that's pulling out this curve. And there are, I don't know if I mentioned it, there are two of them. One of them is what is like in the current facing direction, and one of them is facing into the target, so that it curves into the target. We're then creating a new nav curve, a new Bezier curve. We're setting the start point to the current transform position, the control point 1 to the current the start position, plus the forward out the front of the spaceship at the length of the control point radius, which we calculated up here. So that gets us our first grey line that sticks out the front of the ship and causes it to kind of curve away from its current direction. It's got control point 2, which is the goal position plus the negative goal approach times the control radius, which means that line is away from the goal position, and that's kind of pulling the curve back in, so it will curve in and then coast into the position into the goal position, and then the end point is the goal position. And then we're adding that to the nav curves, and we're setting the state machine to state machine go to, and then that will start evaluating. So the two main things we've done here is we've set the state machine so the state machine is evaluating, and then we've added a nav curve, at least one. Well, we've added one nav curve to the nav paths list, right? And that's important because in the update function depends on what is in that list. So we've got other switch things for going to orbit, going to follow, all that sort of stuff. start method just initializes everything. Oh, this is now into Unity methods. Let me close up this region as well. There's a lot of state machine. There we go. There we go. So now we've got region Unity methods. So we've got the normal start method that basically creates things, sets values to 0, sets stuff to null, and then it starts the run state machine coroutine. So that's all that really does. So in update, this deals with the frame-to-frame moving of the game object around. So this doesn't deal with any state machine stuff. All this does is move the object if there's a curve to follow. So right, where are we? So the first thing it's doing is, sorry, my brain just went like, it's wandered off somewhere. I'm not quite sure what was going on there. So the first thing we're doing is, if the current nav path is null and there is a path to execute, then we want to switch to executing that path. And we're doing that by setting the path progress to 0 and setting the current nav path to the nav path, like the first one in the list. And the idea is, as we remove them from the list, so if you've got a load of them in the list, we remove the first one every time it finishes, and it will go on to the next one. So this update thing just executes the navigation paths in sequence. Current path progress. Right, so if the current path progress is greater than 1, then we've finished. So what we want to do is we want to log that we've completed the path, remove the current path from that nav path list, set the current path to null, and set the current progress to null. So the next time this goes round and does a loop, this will then hit this method and go and read the next one off of the pile, set it to be executed, and then it's executed down here. And then finally, if the current nav path is not null, then we actually execute along the nav path. And what that's doing is setting the current position, the transform position to the point along the path, setting the transform rotation to rotate so that it's pointing along the path. And that's still a little bit weird, but it works so far for testing. And then we're updating the progress along the path by 2%. So this is actually doing 2% per frame along the thing, not 1%. And eventually this is going to have the velocity stuff in here, but right now it's just moving on the path at a set rate. Okay. And then finally we've got the on-draw gizmos, which I'll leave on the screen for a moment. If you want to pause it, you can have a look, but that's basically just drawing the lines and making it look pretty. What I'll actually do is right now turn off that so that it doesn't draw the red lines, which are a little bit annoying. Okay. So there we have it. We have a spaceship that moves randomly around following nav paths. Happy with that. That's the first step on the way to having all the spaceships in the game working. So right, what I'm going to do is I'm going to end the video here. Thanks very much for watching, and I hope you enjoyed it. If you've got any questions, stick them in the comments or stick them on the Facebook group. If you're not a member of the Facebook group, feel free to join and tell us about your project if you got one, and ask any questions about this. So great, thanks for watching. See you later guys, bye.